started. My name is Melody Barrons. I'm a functional nutritional therapy practitioner. That's a mouthful. For short, you can just call me an FNTP. I'm also a CFL1, a CrossFit Level 1 trainer, and I coach here the 6 p.m. class. Where are my 6 p.m.ers? My fire breathers. I got some of you guys in here. And I coach any random class that somebody else can't be at and they need a fill-in. I also do all of the nutrition coaching here, and that's why you came, because that's why we're here. We're here to talk about nutrition today. We're here to talk about something specific, the mystery of macros, this macronutrient mystery, how we use our body as a roadmap, and we're going to actually use some of our organs as keys on the map, and how our body does these interesting processes of processing these macronutrients, and how we're going to talk a little bit about how we've gotten it really wrong, and why some of us might be in a situation where we really need to adjust how we ingest these macronutrients. First thing, what are they? What is a macronutrient? Does anybody in here, you can just raise your hand. You already know what macronutrients are. Raise your hand if you know. I need to know. Yeah. All right. So I saw a lot of hands not raised. This is great because we're going to really dive in today. I want you to look at here. We're going to go over what they are, but we need to clarify something before we even begin today. We need to clarify one term. One term is called homeostasis. Does anyone know what the term homeostasis means? Just raise your hand if you know. No? Oh, yeah. Okay, my people who are already in nutrition, if you didn't raise your hand, we need to talk. So, I can't go high. I'm just going to go here. Homeostasis. This is the body's process of keeping and maintaining a stable internal environment. Now that I said that, do you have an idea of anything that your body keeps in homeostasis, where it maintains a stable internal environment? Huh? Breathing, respiration, yes. What's something else? What's something that can get out of control that your body always keeps in control, and when it gets out of control, you know, hey, I'm sick? Temperature, body temperature, blood pressure, yeah. These things are all kept in a stable environment by your body naturally. You don't have to think about breathing unless you're working out. You don't have to think about your blood pressure unless it gets too high or too low, because your body is trying constantly to keep this in this state of homeostasis where it's stable. And here's the big thing, despite external input or environment. So your body's constantly working to keep these things. One big one, besides blood pressure, body temperature, is your blood pH. So your blood has a certain pH balance. We all know a little bit about chemistry. We know acid, alkaline, right? We've all heard those terms. So your body keeps it in this very narrow margin. 7.35 to 7.45, or we got trouble, right? We have trouble if it gets out of that range. Then we're out of homeostasis. Our body goes into a stress mode, trying to fix it. Another thing that happens, your blood glucose, blood sugar. We'll use those terms interchangeably today. We'll say blood glucose sometimes I might say blood sugar. I mean the same thing. The amount of glucose or sugar traveling through the bloodstream at any given time. This is kept in a very narrow margin. You've all has everybody pretty much, maybe you haven't, but most people, you've had blood work done, right? You've seen your blood glucose level. Your doctor has said, hey, fast before this because we're getting a fasting blood glucose, right? If you've been pregnant, you've had a glucose test. So most of us in here that have done that. So our body keeps it in a really tight range. Why do they measure these things? Because when it gets deranged, then we have a problem. What is the #1 problem we see in America today? Diabetes. What is diabetes? It's deranged blood sugar. It's deranged. So your body wants it to be in this certain window. When we get outside of that window, it goes into this stress mode. What causes that? It's what we eat. Here we go. Now we're going to talk about macronutrients. We know what homeostasis is. Our body's trying to constantly keep us in a stable internal environment despite what we're doing or what we come in contact with. Now, we're going to take this homeostasis and we're going to look at the food that we put into our internal environment from this external environment. All right, let's go through it. Mystery of macros. We're going to use this human body as it's a complex, an intricate system, and it's going to serve as our roadmap. So macronutrients are our proteins, our fats, and our carbohydrates. And we've got some crucial roles of each of these macronutrients on this first page. I'm just going to go through them. I'm going to read them off. I won't be reading a lot, but we're going to start here. So, protein, crucial role of protein. Building block of the body, they're building blocks. Enzymes. Enzymes help build and break down. Muscle. We all talk about muscle, right? We need muscle, right? We come to CrossFit to get some muscle. We need enzymes. So, protein. Building block, enzymes, hormones, especially digestion hormones, neurotransmitters, antibodies. We talked about getting sick, getting a fever. We need those antibodies. And it creates hemoglobin, red blood cells. We desperately have to have red blood cells. So fat, some crucial roles of fat. It's a key dietary nutrient. It is an energy source. It's efficient and long-burning energy. Fats are the main energy source for the heart. Did you know that the failing heart turns to fat as its fuel source? So when someone's heart is failing, it won't use glucose. It only wants another fuel the body makes called ketones. That's derived from fat. Good fats are for building cell membranes. Notice I said good fats. As you get into this nutrition thing, you're going to learn there's a difference between good fats and bad fats. Or less than good fats. I don't know. Is anything, some of them are bad. We'll just go with that. Some of them are bad. They're bad. Fats are required for fat-soluble vitamin absorption. Our fat-soluble vitamins are vitamins A, D, E, and K. If you don't have fat, you can't absorb those nutrients well. Fats are required for adequate use of your protein. Why? Because they're almost always paired in nature. Fat and protein come together. Think of a ribeye steak. Think of it. Are we all hungry right now? Man, I'm pretty sure we're going to have a break and have some taste test of some yogurt in a little while. Is that true? Do we have that? Okay, we're going to have a sample of yogurt in a little bit, so just be thinking about that. Fat and protein coupled together. We got some. All right. Yeah, I could say think of Katie's Swolgurt. It's fat and protein coupled together. Fat slows the absorption of food for proper energy regulation, and it allows the body better nutrient assimilation. What does that mean? Okay, fat's going to slow everything down in our digestion a little bit, and it's going to help us absorb things a little bit better. That's all it means. We want to absorb and assimilate, actually use what we've eaten. My favorite one is fat makes food taste better. It just makes food taste good. Fat has, I was a chef in a former existence years ago, and fat carries flavor. That was our mantra. Fat carries flavor. If you have no fat, you have no flavor. You have to add something else. Most of the time, what do they add when they take away the fat? They add sugar. You add sugar because fat carries all that flavor. Carbohydrates. We're going to talk a lot about this one today. The crucial role of carbohydrates. The body, I want you to remember this about carbohydrates more than anything else today. The body makes carbohydrates. Did anybody know that? Okay, your body makes them. More on that later. Carbohydrates are a quick source of energy. What did we say about fat? Long burning energy. Carbs, quick burning energy. Carbohydrates help break down proteins and fats, so they are necessary. They're a source of fiber. Most carbohydrates have some fiber. If they're natural, they have some fiber. Fiber helps us pull some toxins out of the body. It binds to things like heavy metals and toxins and spent hormones that need to leave the body, and it pulls them out through our waste system. We'll talk a little bit about that. It contributes to our immune function. It takes a team of three, carbs, proteins, and fats, to make our immune system work properly. But again, our body can make those carbohydrates. It's a primary component of proteins, the proteins that cushion our joints. So we all did box jumps or box step-ups and did some jumping around maybe today, and our joints need some cushion. Carbohydrates help build these proteins that cushion our joints. So that's the role of carbohydrates. So the big question we have today is going to be, how do we know how much of each of these to eat? You know? Like, now you know what they are. Maybe you came in and you didn't know the fancy word, macronutrients, but now you know. You're familiar with protein, carbs, and fats. You've probably heard that. And here's the thing. How do I know how much to eat? We're going to use the design of our body as this map. So, 2 of these macros, let's see who was listening. 2 of these macros are used for energy, and 1 is not. Which one was not used for energy? Who said fat? Protein. I'm just kidding. So, protein is that building block. We don't want to use protein as energy. If we start using protein as energy, that means we've broken down our muscle, or we're in a state of disease or some sort of, our body's, it has a problem. There's something going wrong. We don't want to use our muscle as an energy source. Protein is a building block. Fats are, and carbohydrates are our energy. Now, how do we know how much to eat? Here's where it starts getting good. We have 2 macronutrients that have what's called a positive-negative feedback loop built into our body. Who knows about positive and negative feedback loops? Like anything in life that might have a positive and a negative feedback loop. So there's all kinds of things, but we're going to talk about how our body works. So we have 2 macronutrients that have a positive and negative feedback loop, but we have 1 that doesn't. Now, turn to that page that says feedback loop, the feedback loop. We're going to talk about how your body responds to these macronutrients. So protein signals, we have hormone signals when we eat protein, and we have some hormone signals when we eat fat. These hormone signals will tell us, hey, you're full, or hey, you're hungry. They work on a really cool feedback loop when they're not interfered with. So we have 2 hormones. So we're going to talk about the 2 hormones real quick. Ghrelin and leptin. Ghrelin is made in the stomach, and I want you to just remember this. Grr, growl, gremlin. Who gets to acting like a gremlin when you get hungry? Right? Yeah, okay, so grr, gremlin. That's the hormone that says, hey, you're hungry. You need to eat. Gremlin. There we go. Yeah, gremlin. Ghrelin is secreted by the stomach. It's a hormone. It's released by the stomach. It sends a signal to the hypothalamus and says, hey, they're hungry. You need to find some food. We start eating. Then we have another hormone, and it's released from fat tissue, and it's called leptin. I call these the hunger twins. So the hunger twins work together. I eat some food because ghrelin was released. I get full, and my body knows I'm full because leptin was released from my fat tissues. It went and signaled the hypothalamus in my brain, you're done. Now, where did I say I felt full? Brain. How many of you thought you were done eating when your stomach felt full? That's where, this is where we're going to start getting into it. That's where it gets mixed up. So if I'm eating and I get full here, but my brain is still going, I still want to eat. Now we can start seeing we've gotten our macronutrients mixed up. We've gotten our signals confused. Our feedback loop has been interfered with. So we have one macronutrient that doesn't have a feedback loop. I already named two. There's only one left. Let's all say it together. I'll help you. Carbohydrates. Yeah. Okay, I have one macronutrient that doesn't operate in this loop. It's not really too affected by leptin and ghrelin. This one's called the all gas, no brakes food. Carbohydrates have no feedback loop. This is a design by, now we can get into philosophies, world beliefs, whether you believe in evolution or divine design, it's built into us. We don't have a feedback loop for this. It's been known all through ancestry that we don't have our ancestral humans. We don't have a feedback loop for this. The reason for that is because our ancestors lived in a world without convenience. Our human design tells us when we're full and when we're hungry until we encounter carbohydrates. Carbohydrates, I want you to imagine, let's put ourselves in a place. We're a nomad. We're traveling around with our goat herd or our herd of whatever we have, camels, I don't know. We're finding, or hey, let's just all go outside and wander around till we find some carbohydrates. How's that? In Rome. It's going to be a little while. But what's going to happen when we find them? Oh, we're going to eat them. We don't need a feedback loop for that. The reason why we don't need a feedback loop for that is because most of our whole existence, we didn't have convenience. We didn't have carbs on the shelf. 80% of what you walk into the grocery store and see are carbohydrates. If we remove that, you wouldn't have much left in the grocery store. That's a real shift from our ancestral our upcoming. Divine design, whatever you believe, however you believe it, that's how the body's made. That's how we were designed, evolved, whatever you choose to believe. That's where we're at. So we're out here, we're roaming around Rome. We can't find any carbs. When we do, we find a tree full of, right now, peaches. A peach tree. We eat every last peach until we are sick, but we could still eat more. What is that? Why can I do that with a peach or with some, I don't know, Lay's knew it. They said, bet you can't eat just one. They knew. They knew your design. They know exactly how we're built. Bet you can't eat just one. How many of you ever had one Lay's potato chip and said, you know what, I'm good. I'm going to roll up the bag, put it up. I'm fine. No. You get half through that bag, you're like, I can finish the rest. So you're not even full yet, right? Okay. So we know. Roaming around, we find the peach tree, we eat as much as we can. Why did we do that? Because we don't have ghrelin and leptin, the hunger twins, managing that for us. We're not full in the brain. We're trying to get full here. And we have another thing going on. It's called dopamine. Dopamine is that neurotransmitter that's there. It is the reward center of the brain. When we see a colorful fruit on a tree as an ancestral human, our eyes go, oh, haven't found that in so long. It's been a whole year because it's seasonal. I'm going to eat as much as I can. Okay, that's cool. every year, right? Blood sugar is going to be dysregulated a little bit for that day. That influx of glucose into the bloodstream is going to cause a problem for a little bit. You might get sick to your stomach because you ate so much, but that's okay. It's once a year. That's once a season. That's how we were designed. The problem is when we took those carbohydrates, we refined them, and we made highly palatable, sugary carbohydrates, like ding-dongs. And we put them on the store shelf next to the Lay's potato chips, next to the Cheetos, next to the Dr. Pepper. And we said, hey, I can have this anytime I want it. And then what happens is we got on a train, a dopamine train. And we just ride that thing. Blood sugar's all dysregulated. What did we say at the very beginning? Homeostasis. Your body is constantly like, dude, I've got to keep this in line, and you're bringing these external things in here, and we're all over the map. Now the body's stressed. We've got stress going on. So the brain has been studied using highly palatable, sugary, or high glycemic carbohydrates versus some low glycemic carbohydrates. Notice in parentheses down there, I have real food. When we have real food, we have some other components going on, right? In an MRI scan of the brain, it shows that the brain's response in those same pathways, they were activated the same as cocaine activated the brain. The dopamine hit that we get from these refined carbohydrates that are all around us keeps us going back for more. The feedback loop isn't there. That's why we have a problem in our country. So these all gas, no brakes foods, we've said the food company knows this. If you listen to Mike and I, we did a podcast last week on the food pyramid, you can see from how we have recommended foods for a long time, we've recommended these highly refined carbohydrates. We said, hey, yeah, eat complex carbohydrates, right? But what do we normally go for, right? We go for the refined flour breads. We go for the chips. We go for the refined flour pastas, things like that. Those are the foods we're eating. We're not eating broccoli. We're not like, oh yeah, all my carbs, I should have this much carbs. I'm eating it all in broccoli and asparagus and some zucchini, some leafy greens, some, beets. No, that's usually not what we're doing. So this has become the problem in our country. Strawberries aren't the problem. Processed foods are. So we talked about the different macros. Now I want you to flip it over. You're going to see a little name that macronutrient. I want to give you a few minutes. You can team up. How's this? Let's get into little groups real quick. We're going to do this breakout group. And I want you to name P for protein, F for fat, and C for carb. I want you to fill it out. And we're going to see if we can name those carbs, or name those macronutrients. They're not all of them. Oh yeah, if you have a question on what the picture is, just ask me. Some of them might be a little hard to tell. Second from the bottom? Yep. You might have some that are 2 macronutrients. How far are we down the list? Anybody finish? Yeah? Finished? I'm going to start with the top. Time. Time. Yeah, that's good. Time. Okay, I'll start at the top. I'm going to go across the list. Leafy greens. Carb. Onion. Carb. Grains. Strawberries. Carrot. Potato. Tomato. Salmon. Yeah. Yeah. Bell pepper. Drumstick of chicken or turkey. I don't care. I'm not sure which one. Huh? Protein and and fat. Keep the skin on, you got the fat, right? Yeah. And it's dark meat. All right, cauliflower or broccoli, that can be that. Yeah, cauliflower. Carb. Apple. Ribeye or T-bone. Protein and fat. Grapes. We got mushrooms. Asparagus. Herbs. What? Yeah. Eggs. What if I take the yolk away? Bacon. Protein and so much fat. Beets. Gross. Gross is not an answer. Okay. Gross. But they are a carb. All right. Beans. These are one of the few. It's a protein and a carb. Artichoke. Pumpkin. It's carb. Nuts and seeds. What? Okay, this is a tricky one. Protein, fat, carbohydrate, all in one.
Does it vary on the nut or
It does. It varies the fat content on the nut. This is the reason why sometimes, and some of you will identify with this is the reason why nuts, even though they're considered to be a health food, can get somebody off track. Because they are that perfect palatable protein, fat, and carb mix that keeps us right outside of that feedback loop, because there's enough carbohydrate in most of them that we come back wanting more and more and more. So nuts are why you'll hear people say often in different programs that you need to watch your consumption of nuts and seeds, because they are, and what we're going to figure out is they're a perfect combo. They're that perfect combo of protein, fat, carb that keeps you just wanting a little bit more. Plus you add the salt and then you get like, it's good. All right. We're not going to say they're not good. The interesting thing about nuts is most of the nuts that we eat would be very, very difficult to get in nature. So they would be something that you would hardly ever come in contact with. And when you did, they would be very hard to get. Or you might not even know. It took, we were talking about, Steve and I were talking about cashews the other day. Like, who was the first person that decided to eat this? Because the way you get a cashew, if you don't know, it's kind of a complicated process. It grows on the top of this, what they call a cashew apple, and it's in this encasing. It has to be heated. When it's heated, it puts off a gas that burns your eyes. Yeah. So the nut is actually in there, but you have to heat it. It pops. You have to stay back, because when they throw them in the fire, they have to throw them in the fire. They heat. They let off a gas that literally like would burn your skin, your eyes. So to get to that, are you thinking like I'm thinking? Like I would be like, you're in a group of these ancestral humans, and you're like, hey, Logan, I bet you can't eat that apple over there. Throw it in the fire and see what happens. You know, you're getting somebody to try something. Like, who tried that? You had to be starving, right? You had to be really hungry to figure some of this stuff out. I still wonder who was the first person that went, you know what, that came out of that chicken's rear end. I think I'm going to eat it. I always think a lot of this stuff had to go back to somebody was really hungry. All right. So we did our game. We kind of figured out what some of the carbohydrates, proteins, and fats look like. Great job. I thought that would be just something fun to do. But now let's talk about the body. I want to draw a person up here, but I'm so bad at art. So you're good? Could you draw? She's pointing at you. She's saying you are. So like this silhouette human. I give you the expo pin. So just right here is good. No pressure. Yeah, no pressure. Well, it has a big head, and a big head is not bad. That's totally, you can leave it just like that. That is totally fine. Yep. We have no hands. Now you can't even eat. You got no hands. Thank you. All right. So we have a person. Maybe your head's not shaped like that. That's okay. It's a Squidward head. Okay. So our body is essentially a long tube. We've got a mouth. We're a long tube. It kind of squiggles around in here a little bit. But we're essentially this long tube with some organs. We got a heart. We got lungs. But here we are, a long tube. We got these peripheral organs on the side, right? This is our design. We have muscles. We'll put some nice striations in here. That's what we're all hoping for, right? These nice muscles. We'll give some, oh yeah, calf muscles. There we go. Yeah, we got some muscles. We'll even put a booty. Yeah, there we go. All right, so we've got a human being. We start at the mouth and we end. We all know where we end, right? This long tube ends behind that booty. We'll just leave it at that. How are we made? This human that you are 60% water. We left off the most important macronutrient today. The most important macronutrient is water. There are typically, we talk about 3 when we eat, but there's 4, water being the most important macronutrient that we have. But we left that off today just for the reason we're talking about food. You are 60% water. I'll write it up here. You are 18% protein, 15% fat, 7% carbohydrate. That's the way the human body, if you were to break it down, is designed. Now, all of this is made of certain chemicals, hydrogen, oxygen. We've got all the minerals. We're not going to go through all that today. That was our first. We talked about that in our first workshop. I think you could probably go back and see that maybe on YouTube. So we go a little bit deeper into that. So this is the way that your body is designed. This is going to help us understand. Can you already see it? Can you already see the order of macronutrients? Okay. Your body tells you. It is a roadmap of how to do this. So here we are. We want this guy to stay in homeostasis. So if we look at this and we look, this is how we're designed. I want this internal design to be here. We have to control certain things. One of those big things being when we eat, we have to control blood glucose. I'm going to give you a real key fact here. Two macronutrients, no impact on blood glucose. One of them, it can have a lot of impact on blood glucose. Protein, minimal hit on your blood glucose system. That means, here's the key driver of disease, and this is the big word of the day. Hyperinsulinemia. So, hyper meaning too much, insulin being a hormone called insulin, emia meaning in the blood, too much of this hormone, insulin, in the bloodstream. One of these macronutrients can cause hyperinsulinemia. Insulin is the hormone that we have to talk about first. Let's clarify what it is. You eat something sugary, your body gets out of this homeostasis. How? What causes it to get, where's the range? Let me give you the range. The range is, and I'll give you just a person as an example, 165-pound male, healthy, body weight, lean mass. This person has 5 liters of blood in their body. In that 5 liters of blood, in that bloodstream at any given time, to maintain this, there's 5 grams of glucose flowing through the bloodstream. 5 grams. How much is that? 5 grams. 5 grams equal to about 1 teaspoon. 1 teaspoon of sugar. Think of it when you go to Starbucks and you grab a sugar packet. That's the amount your body can handle in the bloodstream without going, we got to go into action. Okay, now it's starting to make sense, right? So we want this. We have this. Here we are. We're good. We're good. Now, when we eat something sugary, to get rid of this, when it goes up, we secrete, or not secrete, we release. Hormones are released. We release insulin. Insulin comes from an organ in the body. Okay, everybody look at your tummy. Right about here, right about in here, right around the stomach, you have an organ called a pancreas. The pancreas, okay, Katie, I asked this, I talked about this on a Zoom one day, and I had no idea there was a Weird Al song called, that we're about to talk about, this one part of the pancreas. So the pancreas is about 6 inches long. So it's about 6 inches long. It has 2 main functions. Its 2 main functions are to create enzymes. We talked about those. Enzymes break down, build up. They help with all of that. The enzymes, the pancreas they secrete their enzymes. They come out of the pancreas. They go and help break down proteins, fats, and carbohydrates. It also releases this cool stuff called bicarbonate that we talked about, acid and alkaline. Food is in your stomach. It's super acidic, or it should be, breaking down all of these foods. And when it starts to go into that small intestine, it's super acidic. So your pancreas goes, that can't happen. That'll burn the small intestine. So you got this thing called the duodenum right at the beginning of your small intestine. It's an opening from the stomach to the small intestine. The pancreas goes, woo, I need to put the fire out on that hydrochloric acid before it hits the intestine so it doesn't burn the small intestine. Because it's like battery acid. So it shoots in some bicarbonate, some enzymes. It neutralizes that hydrochloric acid. That food goes into the small intestine, and by the time it leaves the small intestine, all of your food should pretty much be absorbed into your body and being used as building blocks, fuel, and repair. Once it gets to the colon, the large intestine, we should be dealing with trash. This is the trash. That's the trash heap. Everything going from there, that's just trash. Get it out. It has a few other jobs. We're not going to hit on that today. So here we have the pancreas. We eat pretty often. So it has to constantly do this. That's 99% of its job. 99%. Again, roadmap. Key. Here's the pancreas. 99% of my job is to cool down the hydrochloric acid and to spit out some enzymes to break down some food. 1% of my job is to control blood glucose. Holy cow. 1%. And in my pancreas, I have these little pockets of cells called the the islets of Langerhans. It's such a cool name because it's named after the guy who figured it out. All right, so we have the islets of Langerhans, and because they're called islets because they're like little islands, and they're full of these cells called alpha and beta cells. So alpha cells will tell our body we need to release some glucose from the liver and from the muscles. Your blood sugar's going a little low. We need to bring it back up. It got out of this range. It went below this. So we need some more blood sugar. We got to keep it in this range. Bring some in. So the alpha cells will go and we'll send a message to start releasing. It's called glucagon, is the hormone that gets released. When you eat something sugary, it goes and it releases insulin from the beta cells. The beta cells in these little pockets called the islet of Langerhans release and go clean this up when it gets too high. Where does it go? Right? Where does the glucose go when it's too much? All right, that's the next thing we're going to talk about. We talked about hyperinsulinemia. We're going to come back to that in a minute. But let's go to that little page that you have that says the storage problem. All right, you got skeletal muscle, you got a liver, and you've got a person with some dotted lines. Where does the glucose go? First of all, it goes into liver and muscle storage. We can hold about 2,000, we're going rough, it's anywhere from 1,600 to 2,000 depending on the size of person, it ranges, of glucose stored in the form of glycogen, either liver glycogen, we store less there because the liver is smaller. We store about 3/4 of our glycogen in our muscle, and that's called muscle glycogen. So when you go and you exercise or you need you need your blood sugar, your blood glucose to come up a little bit, fight or flight, I got scared. Your body sends these messages. It releases some glucose to give you quick energy. Remember, it's quick burning energy. It releases it. You got this quick burning energy. Now you can run from the bear, right? That's really necessary. So you have about this much stored in your liver and your muscles ready to use. That's very, very normal. What happens is when we have a storage problem. Has anybody seen the movie Joe versus the volcano? Anybody? Am I the only one? Okay. You know what I'm talking about. You have a luggage problem. I have just the thing. Okay. So you have a storage problem. Your body went, ooh, we're getting a little too much of that. We're full up on the sugar in the muscles and in the liver. We have no more storage. We've got all this circulating around in the bloodstream. A normal thing to happen is it gets put in fat storage. So fat storage has infinite storage. So you see the little dotted man. He can keep growing and growing and growing and growing because he has infinite storage. We all have infinite storage of fat. So we can store as much glucose as we possibly can and just keep going, keep going, keep going. Let's take it back to the feedback loop. No feedback loop, infinite storage. That is how we're designed. But the problem is we let it get kind of out of control. That's there for emergencies. Do you know how much fat, how much energy you have stored in your fat just if you're lean? Let's go back to the 165 male, healthy body composition, has about 50,000 calories of glucose stored and energy stored in fat cells. So we have a tremendous amount of long-burning fuel in our body. But how do we get to it? We're going to talk about that a little bit. The problem is when our blood sugar is constantly raised, our storage problem happens when the skeletal muscle and the liver is full. The fat storage can take some up, but when we tap in and we get rid of that muscle glycogen, something else happens. When we've been doing this for too long, up, down, up, down, up, down, constantly over consuming carbohydrates we weren't meant to. What happens is this insulin hormone, your cells become resistant to it. Your cells say, you know what? Because here's how it works. Here's a cell. There's a trap door here. There's a little door that has to open. There's a key here. Insulin is this key. It connects, it unlocks this door, and the glucose can come in for storage. What happens is after abusing the carbohydrates for so long, this cell, this key, is blocked. It won't take it. It's broken. It's called insulin resistance. Your cell is insulin resistant. It won't accept it. Therefore, that door won't open. When that door won't open, you have no choice. It goes to the fat cell. The fat cell will take it in all day long. It's like, come on, bring it in. I'll take it all day. We got infinite storage. So the problem is chronically abused carbohydrates, particularly the processed, refined carbohydrates. I'm going to tell you right now, nobody ever got into a bad situation by eating real food carbs their whole life. Broccoli, a potato, some fruit. We didn't get in trouble with that. We got in trouble with refined grains, sugar, and highly palatable processed foods. So that's what led us to here, this insulin resistance. So how do we get out of this cycle? Well, that's what we do here at OYL. We get you out of the cycle. So how do we do that? We help you manage how you take in those carbohydrates, and we encourage you to use real food carbohydrates, because those carbohydrates, they have something that the highly processed, highly palatable processed food carbohydrates don't have, that the Lay's potato chip doesn't have. It has fiber in it. It's a natural way. We said it slows things down. It helps slow it down, helps you break it down, helps you digest it, assimilate it, and use it where you need it. And it's very hard, I will say, to overeat a head of broccoli than it is to eat a bag of potato chips. So it becomes a question of like quality of carbohydrates, quality of the food. Was it real? The things we ask ourselves here at OYL is, did it have a mother? Did it grow on a tree? Was it pulled out of the ground? Was it plucked off a vine? If I answer yes to those questions, I'm probably eating a real food. As long as it wasn't processed after it was not processed within reason, right? If it had a mother, we're not going to eat it live. I mean, like within reason, it was processed. So we want food that would sit on our counter and would rot. I don't think that Twinkies fall in that category. I'm pretty sure in 50 years you could eat a Twinkie that was made today and it would be fine. So it would be fine. It wouldn't have any mold on it. I want food that will mold on my counter. That's food. It spoils. It's real. Your body knows what to do with it. Your body doesn't know what these other foods are. And that's where it gets confused. And we're not working within the design. So we're introducing something out from in this external environment that interferes with this homeostasis. And it takes us to this place of derangement in our body. And that confusion leads to chronic disease. All of that confusion inside the body, pulling us out of homeostasis, is the driver of chronic disease, particularly hyperinsulinemia. Too much insulin in that bloodstream. Damaging. It's damaging. And that's what causes heart disease, cancer, Alzheimer's, high blood pressure, and I could keep going. All the chronic disease. Did you know these diseases are called the diseases of man? They're dietary diseases. You can't treat a dietary disease with a pharmaceutical. It doesn't work. You got there with food. You have to get out of there with food. It's the food you choose. Every time we eat, we are either feeding or fighting disease. So that's what we do here at OYL. We have a nutrition challenge coming up. That's all I have for you today. I'm going to ask Jonathan to come up and close us out. We might have time for a couple of testimonials. I don't know what he's got planned for us. But that's the mystery of macros. We got some more body scans to do. We will talk a little bit about that. Hang out. I want to go over that one last thing after we get all the body scans done. Cool.
Clap it up, man. Has anybody